over in this room, quite excited to announce that Gavin's going to be talking to us about rapid fabrication. Thanks, Gavin.
Oh, yes.
I wasn't going to bring this in, but then I decided to use this instead of a trolley, so... Needs so much practice to actually make that look graceful. Okay, so I'd like to talk to you about rapid fabrication, or the PD subtitle was How to Make Anything, Robots Paint with Lasers. First of all, my background, we are living in the future. I don't know if anyone else has realized this, but I've got a couple of things which will hopefully convince you of that today. I'd like to talk to you about some nifty tools that you can use to make things and nifty methods of making things that a lot of people aren't aware of. First of all, my apologies, I've got no idea what the hardware-software split amongst the Open Source Developers Conference is, so I've aimed this hardware-wise fairly basic. My apologies if I'm teaching you how to suck eggs. So I'm a robotics engineer. I'm current president of Robots and Dinosaurs, which is the Sydney Hackerspace. I should probably turn that on. How's that? I am a tinkerer with a short attention span. I'm probably best known on the web for the life size, which is that thing down the bottom there, which makes eerily hovering text in midair in photos. And I'll show you how I made that later on. I'm not author of any projects you see here, and I'm not getting any money out of open source hardware or software. So I probably don't need to convince you guys of that, but occasionally when I talk to other people, they're like, what are you trying to sell us? Yeah. No. Okay, Robots and Dinosaurs. We're a hackspace or a community workshop in Sydney. We're a place where people share tools and equipment, talk on various projects, share knowledge and inspiration. And I cannot emphasize the inspiration enough, because so many projects I've personally started or I've seen other people start because they saw someone else doing something cool and wanted to do it themselves and wanted to make it better or different. We are involved in 3D printing, laser cutting, rocket cars, sand art, metal casting, doll houses, crochet, sous vide cooking. Sous vide steak is lovely. Just about everything else. We have a full-size Dalek and several R2-D2s, as well as K9 and a few other things in the hackerspace. Some of the projects on here, we've got someone that's Alex from Newcastle. He's a 16-year-old. He built his own roving robot and did a fantastic job of it. Bottom there is us chasing the transit of Venus recently, driving frantically around New South Wales and capturing the image as well as we can with our homebrew equipment. And flying days at the park are a fairly regular thing with us, making and flying various RC aircraft. To give you an example of the sort of thing, I didn't even want to try and define rapid prototyping because it's a bit of a thorny issue. So basically, methods of making custom projects that would otherwise be too tricky. If you had to send away for fabricated parts to be made in China or whatever, you'd have the lead times. A lot of projects wouldn't get off the ground. This is a video, a friend of mine, Nick, made this after seeing, again, getting some inspiration off the internet. He made this in a few weeks. This is the prototype, and then he went on to make a much, much larger version. This is Nick's sand table. That's lovely. Come on. There we go. So this is a rotating turntable with a magnet on it. It's a pole-like ordnance system, bigger and radius, and basically over time it slowly moves this ball bearing around and maps out cool patterns in the sand.
That's Nick Johnson?
That is Nick Johnson, yes. He used to work for Google. Nick developed that as a prototype. Fantastic. You've got your output device. What do you do with that? And the answer for Nick was ratemycurve.com. So people log into there and choose which of the two patterns they find most aesthetically appealing, and it breeds them over time against each other, and eventually gets out, he can throw at the sand table and fill his living room with the most web-voted art that you can have. Another good example of a project I wanted to show was this one. It's called My Little Piece of Privacy. I wasn't going to go the whole way through, but this is the guy who had his workshop directly on the street front for a while. I love the reaction when you show that to new people. Actually, implementing that is really straightforward. For anyone with electronics background, it's just one stepper motor and then some power electronics and maybe a so you can start from scratch. It is really simple, but so many people go, that you could never do that. That'd be too hard. And what I'm trying to express today is that we are living in the future. Another project also from Nick, he's really showing us up because he's got so many good projects. Has anyone heard of an FPGA?
Yeah.
Yeah. So an FPGA is a programmable processor. You don't have to. You can redefine what it does by just essentially burning out little fuses in software, and you can make your own thing that routes signals from one place to another. They're really cool. Nick wanted to make one from scratch using only off-the-shelf chips. So what you're looking at there is, I think it's either an 8 or a 16 gate FPGA that he's got. 8 or 16 slice FPGA. And it's totally programmable. It cascades out from one to the other. Totally impractical, but I love that we're able to make this from scratch using only off-the-shelf parts. Also, PCB fabrication is something I'll talk about, and that's well within the range of everyone these days. Those circuit boards, totally custom-made for Nick's project, in the order of sort of $10 for 10 boards. Another machine, damn it, Nick made this one, but it was my idea. He just implemented it first. So we're actually racing to build these. It's an advice machine. So everyone knows the fortune script from Linux or Unix. This thing it's coin operated, and it gives you better advice the higher the denomination coin you put in. So if you put in a 5-cent piece, you could get some positively bad advice out of that machine. And we're going to donate it to a charity and stuff. It was that's an idea. We were kicking around at dinner, and it's like, I bet I can do it before you can. All right. And Nick somehow managed to beat me despite moving to London in the process. So he's really outdone me on that one. No matter how cynical you get, it's impossible to keep up. One tool that we use, which is really, really useful for a lot of these projects, is a thing called Arduino. And again, apologies if I'm telling people something they already know. It's a microcontroller on the board, so it's a little standalone programmable computer, essentially. You have 14 digital pins, 6 analog pins. The programming link is included, and it's just a standard USB cable that plugs into the PC. It's really easy to go. Basically, the advantage with this one, as opposed to a lot of other ones, is it's really, really cheap. It's self-contained. It's expandable because you can just drop shields on top of it, and I'll show you a couple of them in a second. It's free software, and it actually works. What it's not, well, forestalling arguments with my friend Ada. No one will crucify me if I don't mention this when I mention the Arduino. It's not the fastest, it's not the cheapest, it's not the most power efficient. I'm okay and I can live with it. So why do I use it? It's cheap. It works on Mac, Windows, and Linux, and it doesn't need a special cable. It's easy use. I'm not kidding when I say that to use other chip development environments, I have actually have to sign a non-proliferation agreement saying that I will not use this to make missiles. I really don't care. I just want to download it and get it working. So the Arduino wins because I can get it working in a couple of minutes. It has probably the largest user base of any development environment out there today. There's huge amounts of official examples, plus contributed code libraries and tutorials. Have a look in the playground. Odds are, if you want to do something, someone has already found a quick way to do it. A good example is you want to control a media device, someone's done that. You want to do a Twitter, someone's done that. You want to use a mobile phone, someone's done that. You want to decode Morse code, someone's done that. I actually made a device which was a USB keyboard. Fairly standard, lots of people have USB keyboards. My one was Morse, so you can sit there and tap into it, and you will see it will actually start putting the text out in Notepad or whatever. That was actually about an hour's worth of work. Not a lot of effort at all. I just pulled apart. Someone else made a twittering Morse device. I reverse engineered the library from that and combined it with the USB keyboard library that someone else wrote, and done. The hardest thing was actually just soldering and twisting up the wires to my little Morse key. Here's an example of some of the Arduino boards. They're really cheap, they're really accessible. Top left-hand one is the most common. sort of $30, $40. Bottom one is the Mega, really useful, much more I/O pins. You've got in the order of 60 pins with that, and about 20 with the top one. Nano is good for small, confined projects. They're only as useful as the things you can use with them. So the Arduino solved this by making a thing called a shield, which just drops straight on top. A good example, the one with the black plugs on it is a MIDI interface. You've got a Bluetooth device up the top left. You can get low-power Bluetooth devices now, which will talk to your phone of choice. That one there is a data logger, and I think it might be Ethernet as well, or is it USB host? One of those two. At any rate, there are oodles and oodles of add-ons for Arduino with snippets of code, so that they become very, very easy to use. A good example, this one came out recently, it's called the ReadyMate. It has Wi-Fi, an SD card reader, a dedicated MP3 decoder chip on board, and with an audio amp. So basically, it's everything you need to use for small interactive devices. You can program it over Wi-Fi, which is a pretty cool addition that not many people have done before. And $75. That hadn't been released at the time I stole that photo, but the board is actually out now. If you just want to get in there and start playing with hardware, the Grove system is really cool. This is Seed Studio. Note the spelling, there's 3 E's in Seed. Basically, there's a shield that fits on the top of the Arduino. You can plug that into all these devices. You can get dials, you can get thermometers, you can get hydrometers, you can get magnetic current meters, you can get accelerometers. There are so many sensors I can't even start listening. Basically, pretty much anything you want a device to do, you'll be able to find a sensor for that. There are a couple of cool variants of this out there. You may have seen the LilyPad. This is actually a microcontroller, but it's based for fabric applications, so you can make smart clothing. Here's an example. Leah Bukele's turn signal jacket. So basically, while she's riding her bike, she can indicate behind her whether she's going right or left. Becky Stone does fantastic work. She's very big in the maker community in New York, I believe. She does fantastic work. I think she may have invented the LilyPad. At any rate, a good example of how useful something is when you first see the quote-unquote trivial applications. Because if people are only using it to do useful things, then it's a good indication that there's not a, the amount of effort required is probably too much for most applications. So I present the coin slot detector, aka bum crack detector. Sits at the back, notices when you're showing bum crack, and gives an audible alarm.
Are you showing the bum crack or for just passers-by?
For the person showing the bum crack. So I guess you have to wear that around all day. But at any rate, it's a fun art project. One thing people are wanting to get into with making prototype devices and robotics is movement. And there's a few ways to do that. The simplest is to use something like a hobby servo. It's really cheap. You can get these devices for $2 each. Larger ones might be more expensive. If you're after a really high torque one, you can get one that can winch a sail up or something like that. It might be $60. But basically, if you want to make something like this robotic spider here, they were made with the order of $5 motors. So it's very, very cool. It's self-contained. You basically just give it power and the signal, and it tells it where to go and figures out when it's there and when it's not. It has feedback, but only internally. So basically, you give it a signal and wish that it's got there. It can't. If it's stalled, if it's hit an obstruction, you can't actually detect that. There are more advanced devices, but you have to go to something more expensive than a hobby servo. Another good motor you can use is a Cepha motor. These are slightly more expensive and more complex to drive. You're looking at maybe $10 to $30 for the motor and $15 for the controller, but they are extraordinarily precise. To give you an example of how precise they are, the Marilyn Monroe portrait there is entirely made out of very minutely moving the pen over the page for a period of hours. And the sort of polar dithering you get is a good example of the precision. So in all of that time, it's never skipped a single step. So you can control these things to a minute fraction of a degree. There's also a couple of cool open source polar graphs you can download and modify or create your own. Getting data from sensors. A cool way, these guys up top right, sharp distance sensor, you can measure, you can analog voltage back based on the distance to an object. I have robots that use these things to avoid hitting walls, and they're really cheap, simple, and easy to use. The one underneath is similar, but it's more of a sort of Boolean thing. You either hit it or you haven't. What's an example of something you can do with that sharp sensor? Well, you might think you can only use it to detect if an obstacle is there or if a person's walked in front of the device or whatever. Not so. Here's an example of something that a friend and I put together in a couple of hours. What we did was take an old plotter, before they had printers, they had plotters. We moved the sensor in X and Y and record the output of the analog. So we actually made a 3D scanner using about $30 worth of parts. And you can see here's a couple of scans we did this door and the Explorer in that sort of clunky grayscale there. That's a full 3D map. That's not the reflectivity of the door, that's the distance. And the 747 plane there. Those are a little bit hard to see, but they're actually quite detailed in the image. Another cool thing you can do with sensors is measure things like temperature. Every object that's at a finite temperature throws off black body radiation. You can measure this really easily. About $20 for a sensor. You can make your own coffee machines, you can make your own anything that relies on temperature feedback very easily, and it doesn't even have to touch the object it's measuring. Cool. This object here is a 9-degree freedom IMU, so it's very, very similar to what you'd have in your phones, but you get a much clearer path of the data, and you can use it for something like a quadcopter or an autonomous plane. Radiation Geiger-Müller counter, really cool. I'll just start skimming along because I'm slow enough to us. Ink shield. Everyone's seen the Lexmark ink cartridges. Someone hacked the bus, made it interface kit to drive it. So there is this text espresso project where you order your coffee over the net, and by the time you drive to pick it up, it's poured the coffee, printed the last 4 digits of your phone number on the top, and left it there in a receptacle ready for you to pick up. If you want to go beyond an Arduino, which is really not something that's uncommon at all, you can get an FPGA. There's a really cool project out there called the Retrocade Synth, which is actually implementing a whole bunch of 1980s chiptunes, like kind of Atari music, all that sort of thing, in code. Raspberry Pi, I'm sure everyone's heard of that. Come have a look at the case that I've got if you want one for free, no worries. Eggbot. Who doesn't need a robot to robotically decorate their eggs? This is an open source one. It holds a pen in the top and very carefully using stepper motors rotates around and draws and lifts the pen up and down. And you can do all sorts of gorgeous examples like that there. I won't even get into processing, face detection. Okay, CNC machining. Basically, it's like a drill press, but you can control it in X, Y, and Z using code. This is really, really easy to get into. So this is Nick, who unfortunately makes gorgeous projects and makes us look worthless in comparison. That is the large version of his sand table. So that tiny little sand table is just the prototype for his coffee table, which is 1 meter in diameter, which is actually far too large for a coffee table, but anyway. So he made that entirely out of hardwood. It was CNC'd on our large CNC at the Sydney Hackspace, and it fits together beautifully.
With the Dalek activators?
Yes. We have a Dalek and an R2, several R2s and a K9 at Sydney Hackspace, so come check that out. 3D printing. I've actually got my 3D printer running right now at the moment. Feel free to come up afterwards and have a look. It's really easy to get into. I'll talk to you about formats that you can use, STL files or more parametric versions of the code. Laser cutting is spectacularly easy these days. I was talking to someone earlier who said that making something like this would be really hard. And I said, no, this is ridiculously easy. If anyone here can master a programming language, then you can make the files to cut this extraordinarily easily. This is my prototype chessboard, by the way. I wanted something that the computer could play against me, and I'd know how to move the pieces based on color. So this is my 2x2 prototype. So I checked that it was working and fitted before I spent money on wood for a larger version. So all I have to do is go to my code, change from n equals 2 to n equals 8, and recompile it, and I'll have my chessboard.
So if you want to do laser cutting of aluminium or something like that, how does that?
Metals are really, really hard to do because you need a very high power laser cutter. We can score metals, but we can't actually cut through them. Here's some other examples of laser cut stuff we've got. He made a remote control car entirely out of laser cut acrylic, which has been cut and glued together. I made some passport stamps. There's this cool thing called Hackspace Passport, where if you go visit a new space around the globe, you get your passport stamped. and just textures and tiles I really like. Max made these things. These are called Geary tiles. They're used in a lot of Islamic architecture, and they're just really fun to play with. They're actually much more fun than Penrose tiles, and I know I'm going to be a heretic for saying that, but I've actually made Penrose tiles, and they're really frustrating to play with. Like, I highly recommend Geary tiles if you're going to play with them. Here's a dollhouse that Max made, entirely laser cut. Paper glued to it. It's fantastic. It was a present for his niece overseas. How do you get into laser cutting? You need a vector design, so not a bitmap, e.g. Illustrator, Corel, Inkscape, not Photoshop. What you want is a DXF output to send to the laser cutter, but keep your originals because you may need to change stuff and recompile it later. We can't cut every material. There are certain plastics that will create chlorine gas and be bad for people and laser cutters alike, and power levels and stuff. Talk to me if you want to get into any laser cutting. I can tell you what's easy, what's not so easy. Making your own PCBs. I've got a couple of examples of homebrew circuit boards that we've actually made on a CNC mill. That's one really easy way to do it in the same day. So you can see up the top there is actually been made by our circuit board milling machine. And my 3D printer's finished. You can use entirely free software chain to make your code, export it to the machine. Once you're happy with the CNC design, you can send it away for fabrication in China if you want bulk quantities of it. Seed again does a fantastic service. They're the guys that have a Grove system. They do $10 for 10 small boards. Sharing your ideas. With the physical fabrication, a lot of people don't know what GitHub is. They're not in tune with it. There's this website called Thingiverse, which is fantastic for sharing your designs. Half of the stuff that I've got here, I've just been browsing Thingiverse aimlessly, downloaded, hit print, and now I have my own tangible copy of these things. What's really, really cool is that I keep browsing the new list on Thingiverse, and I keep seeing people make an improvement on a model which has just come out. So you've got two people on opposite sides of the globe unintentionally collaborating on this same thing. So one guy downloads it, tweaks it a little bit, and uploads his new version. If you tried to get a top-down design, you wouldn't be able to do it. If you said, I want to design the perfect coach hook, who's with me? It'd stall in committee, but just without even trying to, they're getting unintentional collaboration from all of these people working together, which is, I just really love the idea. If you want to get into some of these projects, what's a good way to start? I always start with a bar napkin sketch, so what is my idea? I work from that to a rough parts list. Okay, so I need 10 magnets and a stuffed badger. How do I imagine the different elements working and what interaction does it have? And what can I compromise to make it easier? So a lot of people say, well, what I want is something that will track people in a room and then react based on that. I'm like, wow, tracking people in a room is really, really hard. Would you settle for it goes off when you walk in front of it? Yeah, I would. Excellent, that's much easier. If you want me to track everyone in real time in the room, that's much, much harder. And then spin several ideas and take the best and be prepared to tweak it later. How to get started, and again, apologies if you guys are already one of the hardware aficionados, but I recommend to everyone the SparkFun Inventor Kit. It's an Arduino, a whole bunch of common parts, and there is a free manual you can download with about 10 or so exercises, which are really fun to work through. Spinning motors, reading back sensors, you've got a couple of cool flex sensors and other weird stuff that you haven't necessarily seen before in there. And number one, find your local hackerspace, jump on the mail list and say hello, because we've got a lot of people interested in making things, and we love to talk about our projects, and we love to hear what you guys are interested in making. So I've got my printer running now. I'll answer questions that any of you guys have got, and if anyone wants to, I'll leave my printer hooked up. If anyone wants to tap me on the shoulder and say, I found this really cool thing on Thingiverse, can you print it for me? I'll just leave it plugged in and running this afternoon if that works. So, yeah, any questions?
Where do you get some stuff there, Jim?
In the tower in Melbourne, it's on Queen Street.
Okay, excellent.
I bought a human skull from there.
Is there any kind of hackerspace there?
Absolutely. There are several hundred hackerspaces around the world. There is at least one in Melbourne called the Collective Community Hackerspace. No one owns a hackerspace. The main guy involved is Andy Gilm. He's a lovely chap. They just set up near Hawthorne, thank you. And there's another one starting up, which is a little bit more north of that, I believe.
Preston.
Yeah, Preston. Excellent. Cool. And there is hackspaces in Perth, in Brisbane, in Canberra, all around the world. So yeah.
Just on that note, CCHS on Freenode is the IRC channel of the Melbourne Hackerspace people hang out in.
Good, excellent. Any other questions? Anyone want to have a go at stuff?
How long does it take to print things out?
Excellent. How long does it take to print things out? These ones here took about 20 minutes. I started it just before I started the talk. These are little screw boxes that just screw together like that. So it's a simple model. Large models like Yoda here, I think Yoda on high resolution took 4 hours. But if you just want a less detailed print, you can do it much quicker. So, if you want to part, I printed that one out earlier.
You're on the Yoda charged?
Oh yeah. The Yoda glows in the dark actually. So Frank got some. Is that visible?
Yes.
Yes. I don't know how to display it for everyone else, but he does glow. Frank got some glow-in-the-dark filament and is fond of printing Yoda, so I owe him thanks for that one.
Is the print head on that thing made by itself?
No, it's not. That machine there is a commercial version. That's called the Up.
Okay.
I have a MakerBot and a couple of ref wraps, and I'm much happier with the Up just because it's a. I know this is heresy, but it just works. If you know what I mean. But there are machines out there which are self-replicating, but as far as I'm aware, they all require.
Okay, I've got some at home from the last time when they demonstrated that.
Just as an example, I forgot to show this during the talk. This is a coin that a friend of mine, Beck, made. She laser cut a plastic blank of the coin, double-sided. This is to celebrate us successfully doing the transit of Venus, a once in a lifetime event the other day. And she laser cut the blank. She cast it in latex. Removed it and did a high temperature metal pour in there, and ended up with the final coin. So I was just really blown away because she actually sort of made every step work from start to finish in that sort of very big multi-step project. So it's the sort of thing which is actually people think is really hard, but when you look into it, it becomes ridiculously easy. So.
Well, that's probably about all the time we have at the moment.
So I'd like to thank you very much. Stick around before There are usually plenty of questions around talk like this because it's quite hands-on and exciting, so I'm sure Gavin will be quite happy to talk to you more about this afterwards. Absolutely.